Hello, my name is Rob Reynolds. Welcome to Mat-073, where today we're continuing our discussion on solving systems of equations. We've done it by the graphing method, we've done substitution, we've done linear combinations, or the elimination method. And today we're going to look at the elimination method again, but this time with 3 different variables instead of just 2 variables. So remember, the solution is going to be x, y, and z. So the solution is actually going to be in a plane in outer space, so it's some x distance out, some y distance over, and then maybe some distance up. So this would be x coming out towards you, y maybe parallel to the y-axis, and then z is up parallel to the z-axis. So again, it's a point in 3D dimensions. So to solve for the system, we're looking for an x, y, and z value that will satisfy all 3 systems. So let's number them 1, 2, and 3 and decide, just like we did for 2 variables, let's decide which variable we can eliminate. And it looks like the z variable here is going to be pretty easy to eliminate. So let's ignore line number 3. Let's work with line number 1 and 2. And it looks like if I just add line 1 and 2, then I'll eliminate the z, which is a good thing. So I'm going to say 2x plus 3y, and again, I'm getting this 3y just by adding the y's together. So the z term will drop out, and I get an 8. So I'm going to call that equation A. That came from lines 1 and 2. So now I have a choice. Since I'm done using 1 and 2, I could use lines 1 and 3, or I could use lines 2 and 3. But I have to still eliminate the z. So here I got rid of z's. Here I'm going to have to continue. I don't get a choice anymore. I've got to get rid of the z's. So if I use, it doesn't really matter, I could use lines 1 and line 3, but then I notice that I have plus signs for both. So I always like opposite signs because I'm a better adder than subtractor. So I'm going to use lines 2 and 3. But in order to do that, I think I have to multiply line 2 by 3, because I don't want a negative z. I want a negative 3z. So let's multiply through line 2. So I'm going to use lines 2 and 3. And my new line 2 is going to be 3x plus 6y minus 3z equals, don't forget to multiply this side, 6. And I'm just going to copy down, this is line 2, and then line 3, I think it's good to go. Why is it good to go? Because I think my z terms will cancel, which is the whole goal, to kill the z, equals 8. So if I add lines 2 and 3, I'll get 4x plus 5y equals 14. And I'm going to call that system B. So now I'm just like down to 2 variables. I only have x's and y's left because I chose to eliminate z's in all 3 of the systems. So now I'm back to the previous section where I have to choose to either eliminate x's or y's. So I've got 2x and 4x, which the common denominator is 4x. 3y and 5y, the common denominator there is 15, so I always choose the smaller number because I'm better with smaller numbers. So I'm going to eliminate the x's because the common denominator is 4. If I were to try to eliminate the y's, I'd have to go to 15. So 4 smaller than 15, let's go for the x's. By multiplying maybe the top equation through by a negative 2, I'll get from my new line A to be negative 4x minus 6y, because I'm distributing negative 2 to every term, equals negative 16. And this 4x is good to go, so I don't have to do anything to that because it will eliminate with my negative 4x. Plus 5y equals 14. And negative y is negative 2, and I finally get y equals 2. So in my answer, x comma y comma z, I only have one answer so far, and that's y equals 2. But it's not hard to find the other answers because all I have to do is take this y equals 2 and plug it into any equation. I'm going to choose to just go right here I'll take this y equals 2 and plug it in right here. So instead of 4x plus 5, the y equals 14. The new y value is 2. So I'll subtract off 10 from both sides. 4x is equal to 4, so x equals 1. And then I'll take this x equals 1 and y equals 2, both of my information, and I need to either go back to the original equations, 1, 2, or 3. And 1 looks pretty simple because I know that the sum is 6. So I know 1 plus 2 is 3, so this has to be a 3 in order to get to the 6. But it doesn't really matter if you go back to lines 1, 2, or 3. In fact, since I use lines 1 to find this answer 3, you might want to plug this solution into lines 2 and lines 3 to check your answer. You can also use a graphing calculator, which I teach in another video about how to type in the system into your calculator and use matrices to solve systems. So you're welcome to look. So here's how the author chose to do it. It's something similar. They also got y equals 2, but eventually they got down to the same answer. So again, here are some rules. Some people love step-by-step procedures. So clear any decimals or fractions. That's kind of makes the problem a little bit easier. Look for two variables. So you start with lines A, B, and C, and you eventually you start with equations 1, 2, and 3. You eliminate the same variable and get down to equation A and B, and then you get down to just like one answer, like x equals 5, and then you do some back substitution. Pull it back into A, and then once you have those two answers, take both of those answers and go back into the original. So let's try this process again. You don't always have to eliminate z, but it looks like z's are pretty easy to eliminate right here. So I'm going to use lines 2 and 3 and just add them up. 3x plus 2y equals 4, and I'm going to call that equation A, the first equation that I found. So now I get a choice. Either I can use lines 1 and 2 to find equation B, or I could use 1 and 3, but I still have to eliminate the z. And again, I've got a negative sign here and a positive sign here, so I like signs to be opposite. So I'm going to choose to multiply the second equation through by 6. So my line A is going to remain the same. My line 1, line 1 will remain the same. 3x plus 9y plus 6z equals 3. But my line 2, remember I'm eliminating the z's, so I had to multiply through by 6. So 12x plus 6y minus 6z is equal to 12. So again, the goal was using, that didn't work very well, using this 6 times this negative z to get negative 6z in order to cancel or eliminate the z terms. So what I'm left with is 15x plus 15y is equal to 15. And then hopefully one of these rules they said reduce or eliminate or try to simplify the, I don't know if it's in here, but I would not call this equation B. I would let equation B, if you divide everything through by 15, is x plus y equals 1. The numbers are a heck of a lot smaller. So I would let equation B be this guy here. So now you have a choice again. You can either eliminate x or eliminate y's, and I'm going to go for the y's because the 2 is smaller than the 3. But in order to do that, I have to take equation B and multiply through by negative 2. So my new equation B is negative 2x minus 2y, if I properly distribute, equals negative 2. My equation A remains the same. 3x plus 2y should equal 4. And adding this up, I'll get x equals 2. I'll back substitute that. I get a choice. Either I can go to A or B. I'll go to B. So I have 2 plus y equals 1 because I just found the value of x, so I'm letting x be 2. And continuing to solve, I'll get y equals, well, -1 if I subtract off 2. So now I've got 2/3 of my answer. I've got an x value, I've got a y value, and all I need is a z, and you can find z by plugging into any one of the equations. I'm going to choose the third equation because, again, the sum is 2. So I know that all of these, I know that 2 plus -1 plus the z better add up to 2. So 1 plus z equals 2. If I subtract off 1, z turns out to be 1. Since I solved for that last answer with equation 3, I would check that solution with either 1 or 2, or even both would be good. Here's how the author chose. Good. They also eliminated the z's. Got equation a's and b's. They didn't do that little trick that I showed you. X plus y equals 1. I like that. For their equation b, they left it 15, 15, and 15. And you can see they just got higher numbers. But it's still same solution and same answer. 2, -1, and 1. Sometimes when I have missing variables, you think that it's harder. Or you think that it's easier because you have less but sometimes this is harder for students because they get lost in translation. So I could eliminate the r's here. I might be tempted to eliminate the r's because then equation 3 just becomes equation b. So if I could use lines 1 and 2 and eliminate the r's, then I would be done. Equation 3 would be, but it's kind of hard because 2 and 7, well, I'd have to multiply the top equation. It's 14, so I'd have to multiply both. So I'm wondering if I can be a little bit smarter about this. Instead of eliminating the r's, what would happen if I tried to eliminate the q's? The q's look pretty easy to eliminate because then I could use this for a, and then I could use lines 2 and 3 for equation b by eliminating the q's by multiplying row 2 by 6. So that was easier than eliminating the r's. But maybe the easiest thing to do is eliminate the p, because here I'd have to multiply through by 6. If I eliminate the p using lines 1 and 3, I only have to multiply the third row by -3, which was smaller than the 6. So I always try to use small numbers. So I'm going to keep line 1 the same, which is just 3p. Well, wait a minute. I can't use lines 1 and 3 because I can't eliminate. I'm left with p, r's, and all 3 variables. Wait. That's okay, because if I use lines 1 and 3, I lost track of what I was trying to do here. I'm going to use lines 1 and 3 and eliminate the p. And then if I eliminate p, then line 2 becomes my b equation, and my a equation is not going to have a p in it. Okay, let's eliminate the p's. I think this will work. So 3p plus 2r equals, see, I told you when I'm missing variables, things get a little bit harder. Even it's harder for me. So let's see. -3p minus 6q is equal, no. I have to distribute this. Now I'm making mistakes here. So let's see. Is that an 18? And then this is a -3. So the deal is you can't add this. So let's just leave equation A as 18q plus 2r equals 8. But instead of that being equation A, I think I would let equation A be half of that. Again, it just makes my numbers a little bit smaller. So if that's equation A, I'm really happy, because if I remember my goal correctly, there's equation A. It only has Q's and R's. I haven't even used line 2 yet, but I'm going to let line 2 be equation B because it doesn't have any P's in it. So I'm going to use the pink and the green systems and solve. Let's eliminate the R's That doesn't matter. R is a 7. So I can eliminate the R by multiplying this equation through by 7. So my new equation A becomes 63Q plus 7R equals 28. I'm just going to leave this pink equation for my B equation because I get the R terms to cancel. I've got a positive and a negative. 64Q is equal to 32, so Q is a half. And then I'll go and take this 1/2. I'm going to go to the pink equation and say this Q is a 1/2. So I'll write 1/2 minus 7R equals 4. Actually, that 4 is the same thing as 8/2. So if I subtract off a half from both sides, I get negative 7R. 8/2 take away 1/2 is 7/2. And then I'll multiply by negative 1/7 so that everything cancels over here. Negative times negative is positive, and the 7's cancel. And over here the 7's cancel, and I'm left with negative 1/2. And then I would take the Q and the R and plug into either 1, 2, or 3. But remember, we've already got an R and a Q. This is why it's so hard, or this missing variables. So we have the R and the Q. We need a P. So don't go to line number 2 because I don't even have a P. So let's use line 3. So P. So line 3 is P minus 6 times the Q equals 1. So P minus 3 equals 1. So P is 4. And then I would probably say P, Q, R, alphabetical is the answer. So P is 4, Q is a half, and R is, what was R? I think R was a negative 1/2, right? Let's see if the author agrees. Yes. They might have worked it out a little bit differently. You can pause the video and look at this. I hope that was helpful. Email me with your questions. Thanks.